Good morning one and all. Today I am discussing about Applied Geotechnical Engineering 18 CV62 Module 3 Lecture Series 1. So this topic concentrates on lateral earth pressure. So here we are discussing about active earth pressure, passive earth pressure and earth pressure at rest. So now we should understand what is meant by a retaining structure. Whenever there is a two difference in elevations are there, so to bifurcate the difference in elevation, so we are suppose if we have this is a ground, this is one elevation and this is one elevation. To have a difference in the elevation, we are constructing a retaining structure. So where the backfill will be the soil here. So it helps in bifurcating the two elevations of soil profile. Examples are sheet pile wall, retaining wall, earth retaining structure, etc. The material which retains the backfill, this is your retaining wall and this is your backfill. The material which retains the beyond the retaining wall, that is called as a backfill material. The position of the backfill laying above the horizontal plane at an elevation of the top of the wall is called as surcharge. So now we should understand what is meant by plastic equilibrium of soil. Plastic equilibrium of soil means whenever any soil which exerts a pressure which leads to the leaning out or inwards of that the retaining structure is called plastic equilibrium of soil, or I can say in one word, verge of failure is called plastic equilibrium of soil. Active and passive states. What is meant by active and passive state? A body of a soil is said to be in a plastic equilibrium if every point of it is on the verge of failure. That means this is your retaining structure, this is your backfill. So the pressure is in such a way that it is in the verge of failure, then it is called as plastic equilibrium. Rankine investigated the stress condition corresponding to this state of plastic equilibrium, which can be developed simultaneously through a semi-infinite mass of soil acted on by number of forces other than gravity. The stress condition during plastic equilibrium can be represented by a Morse-Coulomb equation. You can see here the x-axis is stress and y-axis is also stress. So sigma 3 minor principal stress and sigma 1 is major principal stress. If you plot a Morse circle and a failure sample or so plane you taken, that is alpha f, so that to alpha f you intersect it, wherever it intersects you will get a pole, and perpendicular to the line you draw a tangent, that is the line that will become a tangent to this Morse circle. The intersection of that Morse circle tangent, which henceforth called as a failure envelope, on y-axis will is cohesion, and the angle made by that failure envelope with respect to horizontal will give angle of internal friction. So by knowing the C and phi, by knowing sigma 1 and sigma 3, we can, Morse-Coulomb has proposed an equation that is sigma 1 is equal to sigma 3 tan square alpha f plus 2c tan alpha f, where alpha f is 45 plus 5 by 2. Alpha f is called as failure line, and this is called as a Morse-Coulomb relation. This is playing a vital role in calculating lateral earth pressure. In some cases sigma 1 will be vertical, some cases sigma 3 will be vertical. If it is sigma 1 is vertical, sigma 3 will be horizontal force. Sigma 1 is horizontal force, sigma 3 will be the vertical force. This will decide sigma 1 by sigma 3 or sigma 3 by sigma 1 will decide the active earth pressure condition or passive earth pressure condition. If sigma 1 is equal to sigma 3, then we can say that earth pressure is at rest condition. Now we are discussing about active earth pressure. What is meant by active earth pressure? This is your retaining wall and this is your backfill material. Suppose if the earth pressure is in such a way that the retaining wall will move away from its position, then it is called as active earth pressure condition. So let us consider a Z is the depth at which the minor principal stresses is acting, and vertically the major principal stress is acting, and the minor principal stress is horizontal and major principal stress is vertical, and as long as these horizontal forces are more, so the retaining wall will not remain in equilibrium position, it will move away from its equilibrium position. So now the resisting force due to the shear strength of soil is developed in the upward direction along the failure planar SIP line. The ratio of horizontal stress, as I said earlier, sigma h to the vertical stress sigma v is called as coefficient of earth pressure K. So now when the soil is in active state of equilibrium, sigma h is equal to horizontal stress is equal to sigma 3 minor principal stress, and sigma v vertical stress is equal to major principal stress. If you substitute that value in the equation, sigma 1 is equal to sigma 3 tan square alpha f plus 2c tan alpha f, by considering pure frictional soil, that is c is equal to 0, sigma 1 is equal to sigma 3 tan square alpha f, or sigma 1 if you substitute it as vertical pressure sigma v, sigma 3 if you substitute it as horizontal pressure sigma h, then sigma 1 by sigma 3 so is equal to tan square alpha f, which can also be written as sigma v instead of sigma 1, sigma v by sigma h is equal to tan square alpha f. So this equation will gives a coefficient. That coefficient is called as active earth pressure coefficient, which is equal to 1 minus tan square 45 plus pi by 2. Pi angle is, that is a half angle if you represent it, then K is 1 minus sin phi divided by 1 plus sin phi. This is called active earth pressure coefficient. Next, coming to the passive earth pressure coefficient, this is your retaining wall, this is your backfill material. So the pressure acting on the retaining wall in the other direction is such that instead of moving the retaining wall away from the backfill, if it is moving towards the backfill, then the condition is called passive earth pressure condition. In the active earth pressure condition, sigma 1 is equal to vertical stress. Because of the more vertical stress, the retaining wall has moved away from its position. So in case of passive earth pressure condition, sigma, so 3 will be the major governing parameter. Therefore sigma 1 instead of vertical, so sigma horizontal will be sigma 1. That means whichever is sigma 1, that will decide whether it is in active earth pressure condition or passive earth pressure condition. So now in the active earth pressure condition, sigma 1 is sigma v, therefore it is generates active earth pressure condition. In the passive earth pressure condition, sigma 1 is sigma 3, so sigma 1 is equal to sigma h horizontal force, where sigma v is equal to sigma 3. So in the active earth pressure condition, sigma 1 is equal to sigma v. In the passive earth pressure condition, sigma 1 is equal to sigma h. You can see here, sigma 1 is equal to sigma h. So now if you substitute that value, sigma 1 is equal to sigma 3 tan square alpha f plus 2c tan alpha f for pure frictional soil, c is equal to 0, sigma 1 is equal to sigma 3 tan square alpha f. Here in case of passive earth pressure condition, sigma 1 is equal to sigma h, whereas in active earth pressure condition, sigma 1 is equal to sigma v. Now the equation turns out to be sigma 1 is equal to sigma 3 tan square 45 plus pi by 2. If I substitute sigma 1 is equal to sigma h, then sigma h by sigma v is equal to tan square 45 plus pi by 2. Half angle if you represent it, then it will be that is 1 plus sin phi divided by 1 minus sin phi, that is Kp is equal to 1 plus sin phi divided by 1 minus sin phi. This Kp is called as passive earth pressure coefficient. So then what is meant by earth pressure at rest? This is your retaining wall. A force is backfill force is acting in this direction, an opposite force is acting in this direction. As a result of it, the retaining wall is in the equilibrium position. It will not move either in the away from the backfill or whether it is not moving towards the backfill. Then that condition is called active earth pressure at rest condition. So at earth pressure at rest condition, K0 will be equal to 1. Therefore sigma h is equal to sigma v. So that K0 is called as active earth pressure coefficient, and which is equal to 1 minus sine phi. So some of the multiple choice questions are as follows. So that is, the design of retaining wall is necessary to retain the backfill. Yes, option is A. The retaining wall helps in bifurcating the two elevations of soil. Yes, option is A. Retaining wall example is sheet pile wall. Option is A. The material retains or supports by the structure is called backfill. Option is A. The position of backfill lying above the horizontal plane at an elevation of the top of the wall is called as surcharge. Option is A. A body of soil is said to be in the plastic equilibrium if every point of it is in the verge of failure. Yes, it is true. Option is A. Sigma 1 is equal to sigma 3 transferred to alpha plus 2c tan alpha, where alpha is 45 plus pi by 2 is equilibrium Morse Coulomb failure envelope. Option is A. Active earth pressure condition is given by 1 minus sin pi 1 plus sin pi, but it is reversed. Therefore, it is B. False. Passive earth pressure condition is A. When the stress in the horizontal direction is equal to vertical direction, then the earth pressure coefficient is called earth pressure at rest. So that is option is A. And these are the list of the references which are used for preparation of this material. I take this opportunity to thank Department of Collegiate Education and Technical Education higher officers and students for given an opportunity to present this particular topic to the students. Thank you, students. If you have any doubt, you can feel free to ask.